This next one is a huge one. We will have plenty of episodes dedicated to the normal probability plot and other probability plots because they are just incredibly important for understanding what's going on with your data. So this is going to be just kind of a brief overview and an explanation of why it's in your Capability 6-pack. Okay, so what is a normal probability plot? Well, it plots each point against the probability of a random value less than or equal to the measurement of the normal distribution. Okay, that was a lot. What does that mean? Well, what we're doing is we are actually plotting the probability of getting this point with that measurement based on the mean and standard deviation based on the order in which it occurred. Okay, so we order these from small to large, and we plot them against their probability. So we should try to see a straight line. That's what that red line is. Okay, that's the center line. It's the expected percentile from the normal distribution. Okay, so as we see, you should have lower percents down here, higher up here. And that's because if you remember from a cumulative distribution function, as you go up, the probability of getting a lower value than that increases because a higher value, there's more values below that. Okay. So what else do we have on here? What we see is we have some values. So the chart itself is really great for getting an idea of your data. So if we take a look at this particular example, we seem to be very normal. We're lying right on that line. We have a little bit of deviation going up here where we have some higher values down low. What that means is that we're probably a little lower than we expected. If we were to look at our actual distribution, our capability histogram, we can actually see our lower values, our values below the mean, seem to occur more than the values above the mean. And you know, that's kind of what those values show you. So that's great, but those aren't really numbers. Those don't give us a pass or a fail. That just gives us an idea of what's going on. Well, QESuite is incredible. Instead of just giving you one normality test, it gives you the results of 4 important normality tests because you're probably going to want them anyway. Because as we talked about in our capability video, which I highly recommend you watching, normality must be assumed in order to have reliable capability results, in order to have valid capability results. That's because capability is calculated basically by using the normal distribution. So we need to be able to assume that our data is generated from a normal distribution in order to use capability. So the first one you'll see up here is the AD and P value. This is the Anderson-Darling test. AD is the Anderson-Darling goodness of fit test statistic, and p-value is the associated p-value. Generally, your critical value here is going to be 0.05, but you're going to have to consult your own organization's documentation to see what your criteria is. In this case, most people really just check for the p-value. If it's greater than 0.05, we fail to reject the null hypothesis, which is that the data is from a normal distribution. Okay, so that means greater than your critical value, we can assume normality. The second is the Ryan-Joyner test. RJ is the Ryan-Joyner test statistic, and crit is the critical value based on the number of measurements. So if your RJ is greater than your critical, then you can assume normality. That one's pretty easy. All you have to do is really compare if these two, if the RJ is greater than the critical. KS, the Kolmogorov-Smirnov test. Again, this is another normality test. KS is the test statistic and p-value is the associated p-value. Again, generally a critical value of 0.05. The final one is the Jark-Barra test. This one is sort of similar to a skewness-kurtosis test. This one, the JB is the Jark-Barra test statistic, and the p-value is the associated p-value. Again, generally 0.05 critical value, but make sure you check with your organization.